a line through data. What does slope say? Real meaning awaits.
The moonlit data marsh is a quiet wetland where every shell, reed, and ripple represents a data point. In this landscape, mathematical equations record the natural patterns we see in the environment. We can use the equation of a linear model to answer specific questions about the data we collect, like tracking how one measurement changes in relation to another. As the animals move through the marsh, the notation carved into the landscape tracks those physical changes, turning animal action into a measurable relationship. Understanding the math starts with identifying the physical quantities, noticing what changes over time and what remains constant from the beginning. This model for plant growth tracks height based on the number of weeks. The equation h equals 2.5 times w plus 6 captures that specific growth pattern. To find the predicted height after 8 weeks, we identify our input, w equals 8, and substitute it into the model. In this context, the model predicts an additional $35 in repair cost for every additional year of machine age. This delivery time model, t equals 4 times d plus 12, contains a constant value. Consider what that 12 represents if the distance, d, is 0.
Slope is change per 1. Intercept is the start. Say it in words.
This graph plots the delivery time equation. When we substitute 0 for distance, the first term disappears, leaving exactly 12. The line crosses the vertical axis at 12. This intercept represents 12 minutes of fixed starting time before travel distance is factored in. The intercept shows us the fixed starting condition of a process, while the slope measures the variable cost that accumulates as the process continues. We analyze bivariate data by matching the physical changes we see in an environment to the symbols in our equations. The slope acts as the rate of change with its own units, and the intercept marks the starting point when our input is 0. Look at this final stone. Which mark in the environment proves the mathematical relationship, and how does the heron's physical action make that data true?
The line spoke plainly. Slope told the rate. Interpret your next graph.